Good afternoon, students. Today we shall discuss 5 different topics. The topics are formation of different types of images by convex and concave lens. After that, we shall discuss sign convention for spherical lenses, then lens formula and magnification of lens. Finally, we shall discuss power of a lens. We shall discuss formation of different type of images by a convex lens. The formation of images depends upon the position of the object in front of the lens. We can place the object at different positions from a convex lens to get different type of images. We can place 6 different positions. These positions we consider as 6 cases. Let us discuss one by one cases. The first case, when the object is at infinity, the object means candle or light bulb. So the light comes from infinity. All the rays are in parallel to each other. These parallel rays are parallel to the principal axis. This is the principal axis. This is the light rays. These light rays are parallel to the principal axis. We already discussed the rule for obtaining images by spherical lenses. The first rule, if the light is parallel to the principal axis, pass through the focus. So these parallel rays are refracted and pass through the focus. The image formed at focus. Here the image is formed, but these images is real and inverted. The size of the image is smaller than the object. We can get the point-sized images. The next case, when the object is beyond C. So this is the F1 focus. This is 2F1. We have to place the object beyond 2F. So AB is the object. We always place the object in the left side of the lens and above the principal axis. So AB is the object height. So we have to put the object beyond the 2F. Now we have to take 2 rays. First ray is parallel to the principal axis. So this is parallel to the principal axis. Another ray is passing through the optical center. In all cases, we take 2 rays. One ray passes through the optical center and another ray is parallel to the principal axis. Now first we consider the parallel to the principal axis. This ray is refracted and pass through the focus. Already discussed in the rules session. And the another ray is passed through the optical center. It does not refract. It goes straight. In these 2 rays are intersect at in these places, we get the image. That means A dash and then B dash. It is the height of the image. The image is formed between F2 and 2F2, and the images is inverted. That means below the principal axis, the nature of the image is real and inverted. Size of the image is smaller than the object size. That means diminished. So when the object is beyond 2F, the first ray, that is the parallel to the principal axis, is passed through the focus, and the second ray, it passes through the optical center. There is no refraction takes place. It goes straight. 2 rays are perfect at the position here. The image is formed inverted and the image is formed between F and 2F. The next case, when the object is at 2F, this is the F1, this is the 2F1. So here we place the object. That means AB is the height of the object. Place the object above the principal axis. So let us take a first ray. That means parallel to the principal axis, it passes through the focus. Another ray, it passes through the optical center. It does not refracted. That means it does not change the direction of a light. It goes straight. These 2 lines are intersect here at the position 2F. The image is formed on the lens and the image is formed at 2f, and the nature of the image is real and inverted because the image is formed downward direction. It means real and inverted, and the size of the image is same as the object. Let us see the animation. And the object is at 2f. The first ray is parallel to the principal axis. It passes through the focus, and the second ray it passes through the optical center. Does not change the direction. The image is formed at 2f. That means beyond the lens. The nature of the image is real and inverted, and the size of the image is same as the size of the object. The next case, when the object is between f and 2f, f1 and then 2f1. So we place the object between f and 2f. Let us take a object here. The first ray is parallel to the principal axis, so it passes through the focus, and another ray it passes through the optical center. It does not refracted, that means it does not change the direction. It goes straight. These two lines are intersect here. Image is formed. That means the image is formed beyond 2f. So here the image is real and inverted, and the size of the image is larger than the size of the object. So the magnification is higher. The height of the image is greater than the height of the object. Let us see the animation. We place the object between f and 2f. This is parallel to the pencil axis, so it passes through the focus, and another ray passes through the optical center. So the image is formed beyond 2f, and the size of the image is larger than the object, and the nature of the image is real and inverted. Case 5, when the object is at f. So we place the object at f. This is the object. So now take two rays. One is parallel to the pencil axis, and another one passes through the optical center. The first ray is parallel to the pencil axis, so it passes through the focus. Another ray passes through the optical center. Does not refractor. These two rays are parallel to each other, so the image is formed at infinity. The size of the image will be real and inverted, and the size of the image is highly enlarged. Let us see the animation. Both rays are parallel to each other. The image will be appear at infinity. The nature of the image is real and inverted, and the size of the image is highly enlarged. So case 6, when the object is between optical center and focus. This is the focus. Here the O is called the optical center. So we place the object is between F and O. So this is the object. We take two rays. One is parallel to the principal axis. These parallel to the principal axis, it passes through the focus, and another ray it passes through the optical center. It goes straight. But here we retrace back the two rays. We can get the virtual image A dash and then B dash. So we trace back the two rays. We get the virtual images. So the image is formed left side of the lens. Here the image is formed above the principal axis. The nature of the image will be virtual and erect, and the size of the image is larger than the object. This is the size of the image. This is the size of the object. So the size of the image will be larger than the size of the object. That means enlarged. But the nature of the image is virtual and erect because The image is formed above the principal axis, so it is called virtual and erect. Let us see the animation. Now we trace back to rays, we can get the image. So the image will be formed behind the object, that means left side of the line. Image is formed above the principal axis, so the nature of the image will be virtual and erect, and the size of the image is enlarged